Welcome to the lecture on complex analysis, probability and statistical methods. In my previous lecture, I discussed about what is meant by students t distribution and how to solve the problems related to the students t distribution. So in this lecture also I am going to discuss about few more examples on students t distribution. So this is called the students t distribution table, so which can be useful in solving the problems. To test the hypothesis, this table will be very useful. Example number 4. The 10 individuals are chosen at random from a population and their heights is in inches are found to be 63, 63, 66, 67, 68, 69, 70, 70, 71, 71. So test the hypothesis that the mean height of the universe is 66 inches. So here we have to frame the hypothesis first, that is null hypothesis and alternative hypothesis. So first let me frame the hypothesis. I will take the hypothesis like mu is equal to 66, and that alternate hypothesis that mu is not equal to 66, I will take it here. So since they have given n is equal to 10 individuals, so I can take n is equal to 10. The first thing is we have to estimate the value of x bar. So by summing all the values of x, we can easily estimate the values of x bar here. So x bar will be equal to summation x by n. So it will be equal to 678 by 10. So it will be equal to 67.8. I can write it. So now we have to estimate standard deviation also. The standard deviation is given by 1 by the degree of freedom summation xi minus x bar whole square. So on finding the difference between x and the obtained mean x bar and squaring it and summing all the values of x minus x bars and also dividing that summation by the degree of freedom 9, I will be having x square is equal to 9.067 and the value of s will be equal to 3.011. I will get it. So now I can incorporate all these values in the t distribution equation, that is t is equal to x bar minus mu by the standard deviation s into square root of n. So if I replace all these values here, the value will be 67.8 minus 66 divided by 3.011 into square root of 10. I will get it. On simplifying this further, I will be having t is equal to 1.89. So now I want to check the hypothesis. So since they have given the degree of freedom is 9 at the 5% level of significance, I will be having the value 2.262 here. So the calculated value 1.989 is less than the tabular column value, that is 2.262. So hence we can conclude that the hypothesis is accepted at 5% level of significance, we can say. Next example. A certain stimulus administered to each of the 12 patients is the following changes in the blood pressure. So it is given by 5, 2, 8, minus 1, 3, 0, 6, minus 2, 1, 5, 0, 4. Can it be concluded that the stimulus will be increase the blood pressure? So we have to check for the hypothesis with 11 degree of freedom. The value will be equal to 2.201 they have given. So first let me choose what is actual mean and what is the value of n and what is x bar. So x bar is given by summation x by n. So it will be equal to summing all the x values. It will be equal to 31 by 12. I can write it. So on simplifying this, I will be having the value of x bar is 2.5833. So next is standard deviation. S square is given by 1 by n minus 1 summation x minus x bar whole square. So it will be equal to 1 by n minus 1 by simplifying all the values of x square and the obtained mean x bar value and all. Finding the difference and squaring it, I will be having the value of s square is equal to 9.538. I will get it. So s will be equal to 3.088. I can get it. So now I am going to incorporate all these values in the formula. So let t is equal to x bar minus mu by s into square root of n we are having. So first let us suppose that the stimulus administration is not accompanied with increase in the blood pressure. So we can take, I am going to assume the value of actual mean here by taking mu is equal to 0 by considering these conditions. So now if I replace all these values in the formula of t distribution, the value of t will be equal to 2.5833 minus 0 divided by 3.088 into square root of 12. I can get it. So on simplifying this equation further, I'll be having this equation like 2.8 979. So it will be 2.9. It is greater than the value of the given tabular column, that is 2.201. So hence we can conclude that that hypothesis H0 is not accepted at 5% level of significance. So we can conclude that, so it will be 95% confidence that the stimulus is general, is accompanied with increase in the blood pressure. We can conclude here. Next, the next topic is how to find the confidence limit in case of the t distribution. So this confidence limits is also called as an fiducial limits. So the 95% confidence limit for mean, I mean the mu, is given by x bar plus or minus s divided by square root of n at t of 0.05. So for the 95% confidence limit, we have to use this formula to estimate the confidence limit. This x bar is nothing but the mean of the x values, s is nothing but the standard deviation, and n is given by the number of individuals. So for the 99% confidence limit, the mean is for mu is given by x bar plus or minus s by square root of n at t of 0.01 we can use. So these are formulas we have to use to estimate the values of the confidence limit in case of the t distribution. So we'll see one example related to the confidence limit. A sample of 11 rats from a central population had an average blood viscosity of 3.92 with a standard deviation of 0.61. On the basis of this sample, establish 95% fiducial limits for mu, the mean blood viscosity of the central population. So now we have to check the hypothesis for t of 0.05 is equal to 2.228 for 10 degree of freedom. So now we'll check the confidence limit for the given problem. So by the data we are having x bar is equal to 3.92, what they have given. The standard deviation is given by 0.61. So since the number of individuals are 11 there, so I can take n is equal to 11. So actually we have to find the 95% confidence limit here. So the 95% fiducial limits for mu is given by x bar plus or minus s by square root of n t at t of 0.05. So since all the values are given, I can replace the values here. So 3.92 plus or minus 0.61 divided by square root of 11. So t of 0.05 is given by 2.22 at 10 degree of freedom. So now the 3.92 plus or minus 0.41, on simplifying this part, I'll be having the value 0.41. On simplifying this further, I'll be having 3.51 and 4.33 will get it. So we can conclude that thus the 95% confidence limits for mu is, the mean is given by 3.51 and 4.33. Thank you.